The purpose of this video is to help my students better understand what it means to convert fractions to their simplest form. Now, at the beginning of this video, I'd like to say that my little girls are working on book report homework, and you're liable to hear them in the background, but they're going to try not to be too noisy. We'll start with the definition for simplest form. A fraction is in simplest form when the numerator and the denominator have no common factors other than 1. I'll repeat that. A fraction is in simplest form when the numerator and denominator have no common factors other than 1. Now, we work out of a Carnegie program, and I'm going to try to explain what it means to write fractions in simplest form along the same lines that Carnegie introduces this, so that my students can better understand their homework assignments and what we do in the classroom. We have learned that we can create equivalent fractions by multiplying a fraction by a form of 1. And when we say a form of 1, we can use 3/3 as an example. Anytime your numerator is equal to your denominator, you have a whole, and this is an example of a form of 1. And through the multiplicative identity property, anytime your fraction is multiplied by a form of 1, your answer will be a fraction that has the same value as your original fraction. For instance, if we were to have 1/4 and we multiplied it by this form of 1, 3/3, 1 times 3 would be 3, and 4 times 3 would be 12. Now, the same way that we can make equivalent fractions by multiplying a form of 1, we can also find the simplest form of a fraction by dividing it by a form of 1. Excuse me. For instance, I'll take that same 3/12 that we have here, and I'll divide it by 3/3. And when we do that, 3 divided by 3 equals 1. 12 divided by 3 equals 4. And we're back to simplest form. And once again, the definition for simplest form is when the numerator and denominator have no common factors other than 1. Like here we have a 1 and a 4, and the only common factor they have is a 1. When we were with 3/12, the common factor that they had was 3, because 3 would go into 3 one time and 3 would go into 12 4 times. Now let's look at this example that we have here, but allow me to clear my board for just a second. Let's say that we have a fraction such as 9/24. Now, when we want to convert that to simplest form, we can think about a factor that they have in common. Now, we'll get into discussing how the greatest common factor will help us get to simplest form, but let's pretend for a moment that we're not that proficient with determining the greatest common factor of two numbers. Let's say that we can just figure out what a common factor is. So if we have 9/24, I can think of, we'll say 3. We'll try 3. It's a common factor of both, and we'll see how that works. So we're essentially going to say 9 divided by 3, and then we're going to say 24 divided by 3, and we'll see if our resulting fraction is in simplest form. All right, 9 divided by 3 will give us 3. 24 divided by 3 will give us 8. So 3/8 is our resulting fraction. Now, is this in simplest form? Are there any other common factors besides 1? And the answer is no. There are no other common factors, so we indeed have the simplest form for 9/24. Let's try again. This time, let's try 12 over 24. And let's say that we think maybe 6 is a good factor to use. So we'll say 12 divided by 6, and we'll say 24 divided by 6. Now, 12 divided by 6 will give us 2. 24 divided by 6 will give us 4. Do we have 12 24ths in simplest form? Well, it looks to me like we don't. I still see one more factor that 2 and 4 have in common, and that would be 2. So I can go and say 2 divided by 2 and 4 divided by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. So the simplest form for the fraction 12 over 24 would be 1/2. Now my students are going to be required to complete an assignment where they are shown problems like this, and they have to determine if the fraction, sure enough, that results at the end, is in simplest form. And if it's not, such as in the case here, they have to continue simplifying it until they do get to the simplest form. The next activity that my students are going to have to do will be to identify fractions that are simplified completely, and then they'll have to explain how they know. And they're going to see fractions such as 9 over 15. They may see fractions such as 8 over 16. They might see fractions such as, we'll say, 4 over, we'll say, 72. And then they have to identify, are they in simplest form? And how do they know? Well, if we look at 7/15, we know that this one is in simplest form, and the reason we know that is because there is no other factor in common with 7 and 15 except for 1. 7 is a prime number, and its only factors are 1 and 7. 15 is a composite number, and it has factors 1, 3, 5, and 15. Since they don't share any other factors in common except for 1, this fraction is in simplest form. Let's look at this one. Now here we have 8/16, and just by looking at that with my knowledge of basic math facts, I know that this is not in simplest form. I know that 16 is a multiple of 8. I know that 8 is a factor of 16. I know that this would simplify down to 1/2 because 8 will go into 8 once and 8 will go into 16 twice. Here we have 4 and 72. I know that this is not in simplest form because 4 is a factor of 72 and 72 is a multiple of 4. I know that 4 will go into 72 18 times. Just to prove that, we can say 4, 72. 4 will go into 7 one time. 1 times 4 is 4. 7 take away 4 is 3. Bring my 2 down, and 4 will go into 32 8 times. 8 times 4 is 32. Now, I knew that this was not in simplest form because I know that 9 times 8 will go into 72, and any number that 8 will go into, 4 will go into evenly. So we know that 4 will go into itself one time, and we know 4 will go into 72 18 times. So my students will have to look at fractions and determine if they are in simplest form, and if they are, they can just simply circle the fraction. If it's not, they will not circle it, and they can explain that they know that fractions are in simplest form when the numerator and denominator have no common factors other than 1. My students are also going to be required to simplify fractions using prime factorization. I'm going to do one as an example. Let's say we have 15 over 20. Now, we're used to using factor trees to help us find the prime factorization of numbers such as 15 and 30. And I'll show how we did that. We would always say like 15 can be factored down to 3 times 5. Those are both prime numbers, so I'll go ahead and circle them. So we could write down 3 times 5. Now 20 could be factored down with 4 times 5. 5 is prime, I'll circle it. 4 is not, that would be 2 times 2. Those two numbers are prime, and I could then say 2 times 2 times 5. Then, in order to find the simplest form, to take away any common factors they have other than 1, I could cross out this 5 and this 5. And then, here I have a 3, and here I have 2 times 2. They have nothing else in common left. So I could then say 3 over, and 2 times 2 is 4. So 15 over 20 is equivalent to 3/4. I'll do another one. Let's say we have 8 over 24. Now, I don't want to have to do prime factorization with the trees. I'm going to see with my mental math if I can do the prime factorization without using the trees. If I have 8, I know that that could be 2 times 4. I'm not going to write 4 down because that's not prime, but I know that 4 is made up of 2 times 2. Now, if it's impossible for you to come up with a prime factorization just doing mental math, by all means use the factor trees. However you get to the right answer is fine with me. It doesn't matter to me if you use mental math or if you use the factor trees at this state. Because to be honest with you, my favorite way to do simplifying is by using the greatest common factor, which we'll get to in a minute. But this is just one more method that students can use that might help them. Okay, so here we have 24, and I'm thinking to myself that 24 could be made up of 3 times 8. Now, I already know what 8 looks like factored down, so I'm going to write that down. 2 times 2 times 2 times 3. So all I have to do now is just mark out everything that they have in common. I'm going to take out this 2 and this one, this 2 and this one, this 2 and this one. Now I know some people are going to be looking at this and think you have nothing left for the numerator. That's not so. Even though we have taken out all the 2's, it's just understood that we have a numerator of 1. Because all numbers have a factor of 1, it remains. So, because we have no other factors here, we just have that 1. Because think of it this way, 2 times 2 is 4, 4 times 2 is 8, 8 times 1 is 8. So that 1, we just never do write it down because we just don't. So I'm going to write 1 there because that's what would be used in the place of no other factors. And then I'm going to take this 3 and I'm going to put it here because we have no other factors in common. So 8 over 24 works out to be 1/3. So this is just one technique of simplifying fractions to simplest form. You could just write down all the prime factors of that number and then cross out the prime factors that they have in common. What you're left with will be your simplified fraction. Now, the other technique, which I said was my favorite, is simply using the greatest common factor to simplify a fraction. Let's use the fraction 24 over 28 in this example. Now, I could do the prime factorization with the trees if I wanted to, and I'll do it. It won't take me a second. 24, we could say is 3 times 8. And 8, I want to say is 2 times 4, and then 4 would be 2 times 2. So we have 2 times 2 times 2, or 2 to the third power times 3. And we've already talked about exponents in an earlier lesson, so I'm not going to go through the explanation at this point. 28, and I'm going to change the color just because we're going to be pretty close here, and I don't want to get lost. All right, 28 can be factored down to 7 and 4. And then 4 can be factored down 2 and 2. So this would be 2 squared times 7. Now, very quickly, to come up with the greatest common factor here, I know that they share 2 2's, and that's it. 2 2's. There are 3 2's here and 2 2's here, so 2 2's is the greatest common factor. 2 times 2 is 4. So if I divide 24 by 4, I get 6. If I divide 28 by 4, I get 7. So the greatest common factor, 4, will help us simplify 24 28ths to simplest terms, 6/7. I'm sorry I got speedy at the end, but I'm running out of time. Thank you for for watching.